Hi, Mansai.
Hello, Dina, how are you?
Fine, thanks. Are you having lunch?
No.
Just checking how comfortable you in the dining room.
Yeah, no. You see, I recently moved to this house, so
Okay.
nothing is in order here.
Okay, good, great. Rudolph, are you there?
I'm here. We are about to begin. I thought I'll give it a so after one.
Okay, you'll set it up, right? Thank you.
Okay, cool. Okay, I think we are ready to start. So good afternoon, ladies and gentlemen. Welcome to today's webinar hosted by the South African Institute of Physics. I am Rudolph Erasmus from the University of the Witwatersrand and also the South African Institute of Physics Council member hosting this webinar today. So the webinars that are hosted by the Institute have the purpose of communicating to the community at large on several topics. And the very relevant topic of renewable energy is being addressed today by Professor Mantsai Diale. So if I can just ask that people hold off with questions and answers to, after the end of the presentation, and where I'll then give an opportunity for people to raise their hand or in the chat post a question. So I think most of us are very familiar with the research work that Professor Diale does and her involvement in the physics community in a wider context. But I'll give a short biography anyway. So Professor Diale is a professor of physics at the University of Pretoria and also a South African research chair in clean and green energy. Recent developments in her lab have been the successful development of perovskites and hematite materials for solar energy collection and storage. In addition, her polymer solar cells are at the commercialization level, where she has successfully replaced TCO for simple and cheap devices. She specializes in the physics of optoelectronic materials and devices. She's also an active member of the South African Institute of Physics, the American Vacuum Society, and the Materials Research Society. Professor Diale is a founder and active member of Women in Physics in South Africa, known as WIPISA, and she believes that more women and girls must be encouraged and mentored to study and take up careers in physics. So we have the great honor of being addressed by her today with the title, The Role of Physics as a Basic Science in Solving Energy Security in South Africa. Over to you, Professor Diale.
Good afternoon, colleagues. It has been a long time that we have met physically. We definitely are missing each other. We were lucky 2 days ago, we were hosting Women in Physics workshops, so where we saw Brian and other women in physics. Thank you so much. Thank you, SAIP, for trusting me to be the one who delivers this lecture. Next slide. I want to say in this Women's Month, Happy Women's Day to all of us. We really need to be together and advance the women issues in the country, especially after terrible incidents that happened in Krugersdorp to our daughters. I encourage all males to join us in the fight against all forms of discrimination and abuse of women, GBV. Thank you. Next one. Okay. Now, in 2022, the International Year of Basic Sciences was proclaimed by the 76th session of the United Nations General Assembly on the 2nd of December 2021, stressing that the applications of basic sciences are vital for advances in communications, medicine, industry, agriculture, water resources, energy planning, environment, and all forms of needs for mankind. Therefore, we need to use the basic sciences and support them so that we can come to a point of promoting peace through improved collaboration towards sustainable development goals of the United Nations. So I like saying life is dependent on basic sciences. There's your physics equation, kinetic energy and potential energy. Every one of us where we are right now, we are in a state of some potential energy where our mass and the height where we are seated and the gravity are all taken into consideration to understand physics. And we know that the kinetic energy depends on our movement, which is quick and simple, like Brian Habana, who will hit you so hard. That's when we can calculate the kinetic energy thereof. Next slide. So International Year of Basic Sciences is led by the International Union of Pure and Applied Physics, the IUPAP, to proclaim the year 2022 as the year of basic sciences for sustainable development. So UNESCO is the lead agency and focal point for the year 2022. We have started early this year with South African Institute of Physics. Last week on the 1st of August, I was presenting for the government for the DSI South African National Science Week on this important subject of basic sciences. Next slide, please. Basic sciences are defined as the scientific disciplines of physics, chemistry, and biology, with mathematics, where many of us know that mathematics is a language of most of the sciences. And in many times we have thought that biology is not really that important. And I want to say to all of us, biology is so important in the energy issues, where we understand that the first solar cell in the whole world is found in the leaf of trees, these green leaves. The color green on the leaves are showing us that that chlorophyll is due to the absorption of light. And if you put a plant in a place where it cannot get light, the green will not be there. Therefore, the processes of photosynthesis vis-a-vis the solar cell will not be achieved. Next slide, please. So the basic sciences are there to support the sustainable development goals, which are crazy. You know, we really want to achieve by a certain year, which is very close now, 2030 agenda, where we are trying to reduce the hunger and give people clean energy and sanitation and give affordable clean energy. So all of these 17 development goals, sustainable development goals, are very far from us. But as physicists, as lecturers, as researchers in the basic sciences, we can achieve some of these goals. Next slide, please. Generally, we are in a global energy crisis. You know, shape the future of energy by materials and infrastructure. I have had some students thinking that materials is oversubscribed, everybody's doing material science, but that's not true. You can use light to understand these materials. One topic that I enjoy most is the interaction of light with matter, which is addressing the understanding of which materials you want to use for solar energy. So if you look at the effects of the war between Ukraine and Russia, you can realize that definitely we are in that global energy crisis. I remember in 1973, I was a very young person, but understood how expensive petrol was. That when you're traveling very far, you had to get permission to put some petrol in your boot, so that you don't get stranded somewhere along the way because of the sanctions. Okay, let's continue. Next slide. Nature is funny. Go back. Yes. Nature is definitely funny. The way I like to teach physics very well you look at entropy, and I call it nature's tax. Entropy is simply a measure of disorder and affects all aspects of our daily lives. Recently in April, we had those floods in Natal. And all this picture shows you that due to the floods, nobody was saved. People who were in their nice apartments, the power of the water came in and swept them from underneath. And this is what happened. Look at those cars, the way they were swept by the water. Some people thought they can go through it, through the flood and win, but the nature did not allow that. Nature was angry on that day. Next slide, please. Then what is there that is energy? We are looking at our problems of electricity in the country, the presence of electric charge, which can either be positive or negative, produces an electric field. And that's when you get that bulb burning, which is your electricity. That's what we want in our houses. And you know that the light is a stream of particles. You can see that through, when light goes through a prism, it disperses into different colors. I hope I'm still having the terminology very well. And then that's when you can measure the energy from light. It's mass times speed of light, and then momentum. And all of this are related to the speed of light. And all that we need with this energy sustainability in our country, we want to have lights on in the night. We want to have lights on when we need to study. Thank you. Next slide. So our case in South Africa is that we have got this continuous load shedding. And all of us look at the culprit, which is Eskom, and we look at what Eskom has done. We have this nice light bulb where it's an incandescent light bulb or a KZN lamp or KZN light globe, as we generally call it globe. It's an electric light with wire filament heated until it glows. So there's a lot of physics in there. Why do you close it with glass? The filament is enclosed in a glass bulb with a vacuum or inert gas to protect the filament from oxidation. So if you can take this light bulb, which is everywhere in every house, and explain to a normal person, a gogo or your grandfather or anybody, how does it work? Then you'll have done a great job. So Eskom want us to have a light bulb where we are using matches or candles to light our socket, to light up our houses. But you know, that's very difficult. Next slide, please. So we look at the present energy sources in South Africa. We have been using coal, and we are closing this coal-powered plants gradually. We don't have to be rushing to close this coal-powered plants because you can see that because of Russia crisis, Germany has started to import coal from South Africa to reactivate their coal power plants as Russia is curbing the gas flow. And the paper that you see there, written by one of my colleagues, Igor Lubrumeski, with his other people at Weizmann Institute of Science, they have proved from the chemistry point of view that actually coal from South Africa is still cleaner as compared to coal from elsewhere. So whilst we are working towards changing from coal, going to other forms of energy, we must understand that our coal is not that bad. And if we close this coal powered plants very quick, we are going to have other problems, societal problems, increasing unemployment, and making people angry, and we don't want to see our people angry. Next slide, please. So this energy cases for South Africa, we have spoken about coal. There is a lot of coal in Mpumalanga, in Witbank, around those areas. But there is also, the second one is nuclear energy sources, which I'm not going to talk too much about. We have this picture here, the nuclear power plant, which is Quebec in the Western Cape. And it is a very important center for us who are in physics, because most of the employees at that place are graduates of physics. And why do we still have unemployed size graduates in physics? Is that maybe they are not trained properly. So we need to invest as South African Institute of Physics in training and retraining those who are not understanding this nuclear energy, that they be able to be trained such that we can employ them at Quebec in Cape Town and in the coal technologies and move on to renewable energy, solar and wind. I just like to work with equations, you know, power. We like saying, oh, there's no power. We mean power is work done over time, or force times displacement over time, where displacement over time is actually speed. So power is force times velocity. And I like so many different equations that we can have. The equations in the first quadrant there are about voltage, because our power has got a dependence on the voltage. And the second quadrant is the power that we talk about. The third quadrant is the current, and the fourth quadrant is resistance. So we speak this language and it's very interesting for us and we enjoy it. Can we go to the next slide? So what is that we'd like to achieve in South Africa? And applying our knowledge of physics is that we should be moving to solar energy. And where here you have got your solar panels and then a wind turbine there. We have proved that through science, through physics, that you can store solar energy in the wind turbines. Next slide, please. Okay, let's go back a little bit. Go back. Yes. We must be aware that these slides, this blue, the solar panels are actually from silicon. And we are the people who have worked hard to make sure that silicon has been extracted from sand so that we can make these solar panels. And we can speak about the price of these solar panels. Many years ago, in 1976, it was like 76 rands per $76 per kilowatt hour. But now it has gone lower, up to like 15 cents, US cent per kilowatt hour. So, but it is still very expensive for an ordinary person to have this kind of energy being used. But if we can find ourselves having solar panels in over every roof, in every house in South Africa, which becomes your independent power supplies, then we'll have addressed the issues that are related to climate change that makes the environment to behave in a way that we have seen by the coast in April. Next slide, please. So whilst we say solar energy can be stored, I've just shown you one by the wind turbines. We can also save solar power by this lots of batteries, and we feed the grid there so that we can share it. So what is South Africa in need of is some policies about giving this power to the grid. I heard yesterday they were debating about if you are using solar panels, you are going to pay Eskom 900 rands for giving them, for giving them this electricity. And yeah, it's not nice. We can also store this energy by the hydrogen, where we have seen the president earlier in May when he was launching a hydrogen power plant in Limpopo for a certain mine. So we are gradually going there, but physicists, we need to be in power with training our students, because they are the ones who are going to take up these jobs with understanding this, not the engineers' work. Next slide, please. So to address this energy crisis, we need to go into renewable energy and see the renewable energy business opportunities. For example, installation of solar panels. For training, we still need a lot of calculations that should be done for these solar panels. When they are on the roof, how much are you producing in the house and how much are you giving to the grid? Also, we need to talk about policy, where the grid, the government should be coming up with some solutions on how they are going to pay back to those who are giving to the grid. So the load shedding can be solved very quick. Install solar panels, invest in knowledge. South Institute of Physics, you could be adding value by influencing the education system of South Africa, such that in the undergraduate, graduate level, there is some teaching about energy in the solar area, and educate people also about price. Recently, a bank, I don't want to name the name of the bank, came to me and asked me to prepare a training course for their employees so that they can sell with knowledge. So there is a lot that can be done with this renewable energy. So the other picture there, you can see really how does it work. The sun shines on your solar panel, and then there's a charge controller, which goes to the batteries as bank, and then it goes to the inverter, which takes it to the house, and it can take it to the generator for those times when you say, what happens when the sun goes down? Because this is available when the sun goes up. The next slide, it's about, next slide, materials that are important for the making of the solar cell. The base material for making the solar cell is still silicon. There are other materials like gallium arsenide, cadmium telluride, copper indium, gallium selenide, and new materials, because silicon is well established, need to match silicon material properties. So as we go into other materials, all that we are trying to say is that, is it possible for us to beat silicon? Because for an ordinary person, silicon is still expensive. While silicon has reached its maximum cell efficiency around 22, 25, some people once in a while, they will report something bigger like 32, but there are newer materials like perovskites, which has in the last close about 10 years, since 2009 up to 2019, even now, they have gone past the solar cell efficiency of silicon. So what we are trying to do is, can we integrate the perovskites with silicon? But silicon is extremely stable out there, while perovskites are not stable. So the big problem about perovskites is stability of the material in a humid environment. Thank you. Next slide. So you can see the physics there, the basic design of a solar cell. If you look at the bottom part there, you can see a P junction. The P material, how is it made? It is the work of physicists. the N material, how does it come to be that? And the light shines on the material, and then electron hole pairs are created. And then the holes will run to the section of the N type, and the electrons will run to the section of the P type, and they will create that depletion region there. And then the current is able to flow due to these charges. All those other pictures are just showing you the different architecture of the solar cells, where you have the base material, and then which is generally your N material or your P material, depending on what is your purpose about this PN junction. But this is, and then the fingers on top of there, that helps to move the current around. It is metal contacts. These fingers here are metal contacts. Thank you. Next slide. What we need to be doing in solar energy research is to enhance our light capture in solar cells. Our materials are able to capture the visible very well. The IR, the UV, is not suitable because it cannot capture the visible light due to its high band gap, and the infrared is far lower. So we need to have materials that will take both silicon, which is taking some little part of it, and mix it with iron oxide, which is able to take 40% of this light, visible light, and put them together. Our research must be such that we are able to put materials together so that we can produce a very nice device that will capture a lot of this solar energy. And that in that way, we say we are maximizing our light capture for solar cells. Next slide. What is there that you can do? In our research, we have suddenly these days gone into nanostructures. Nanostructuring is also a way of increasing light absorption onto materials. You can see in that picture we have got in your bulk material, you can have dendrites, you can have nanoparticles, you can have mesoporous material, you can have nanorods, nanotubes, nanosheets, nanocones, cauliflowers, and all of them are on a glass substrate where we are using either fluorine-doped tin oxide or we are using any other substrate for absorption of light. And here is when we have hematite, which is iron oxide. Let me talk a little bit about iron oxide. Iron oxide is a very wonderful material that we use for the water splitting and extracting hydrogen because it is able to absorb up to 40% of the visible light. And we're saying, how can we enhance that? We enhance that by using nanostructures. Next slide, please. So, next slide, please. Next slide. Okay, so with silicon, we can use metal nanoparticles, which, yes, metal nanoparticles, whether you put them on top of the surface or you put them inside the semiconductor or on the under the semiconductor on the substrate, it depends. That's the kind of research that you are doing. And this kind of research with metal nanoparticles is that metal nanoparticles are able to produce plasmonic electrons in such a way that they are confined in the metal so that when light comes in and hit a nanoparticle, the light can move around and be confined into the semiconductor to maximize absorption of this light. In general, in this kind of solar cells, silicon has been used, but you add on top of your substrate other semiconductors, other materials like P3HT, polymer, or P.PSS, and you embed this with metal nanoparticles. So there is a lot of work that can still be done on this. And in this other picture here, you can see that light comes from, it can even come from the substrate to make sure that light is confined around the metal nanoparticle. Next slide, please. Go back to the previous slide. There is a slide that I've jumped, so I just want to go back there. Yes. So in this slide, what we can see here is a kind of work that we are doing in our lab, where we are producing these nanorods with different methods that we have in the lab. We are using spray pyrolysis, we're using electrodeposition, we are using spin coating, chemical bath deposition, which actually is not easy for a physicist who comes from these other materials. In our laboratory at the University of Pretoria, we have a molecular beam epitaxy, but people from everywhere in the world, they'll tell you that, oh, that device, that piece of machine will take a lot of energy in producing cleaner energy. So the questions goes about that, is it really important for us to use materials that are so expensive to produce so that we can produce cleaner energy? So it's a chicken and egg situation. What has come first? And then all that we are trying to do is that we need to absorb as much light as possible. That's why we take our basic semiconductors like silicon and make sure that we use other semiconductors like polymers to enhance the absorption of light with metal nanoparticles. What we've done a lot in our lab these days is that we have used the nanorods to produce hydrogen from hematite. And as I have already said, hydrogen will give you about a lot of storage. And then when we look again at hydrogen, is that hydrogen is a very clean technology that can be used in South Africa to address this immediate need for us to curb the load shedding issue, but still also address the cleaning of the environment to mitigate the carbon footprint and therefore reduce the climate change effects. As you have spoken earlier, that energy can solve many problems. Problems of agriculture, problems of medicine. Your solar panels, you can see solar panels are springing up on every roof these days, every roof. I have seen in one shopping center here at the Colonnade, they've just installed lots of panels, solar panels, so that they don't lose business any longer. It is said that there are lots of solar panels at the mining industry in different mines. In Roslyn here, there is an industrial center here called Roslyn, where they plant BMW, where they assemble the BMW. They've got their own solar panels. Therefore, they are no more losing business due to load shedding. So the effects of load shedding in South Africa is the fact that we are losing a lot of business. And the next thing our funder, NRF, will be saying to us, we don't have money. And we are not able also to go to private businesses to fund physics. So what we need to be doing as physicists, solving the issues of solar, of energy crisis, load shedding, it is to make sure that we train many of our students towards understanding solar energy so that we can get our funding also from private businesses. Yeah, thank you. I think I can just go up to here. Thank you very much. I want to acknowledge my funders. Go to the last slide, please. Okay. We are funded by the University of Pretoria. As you are sitting in their offices there, we are funded, the chair is funded by the National Research Foundation. And we are funded also these days by SANEDI because we have incorporated agriculture and solar power. Yeah, there are very interesting things that we are doing. Let me talk about the research that I am doing just in a nutshell. We are doing the device development, photoelectrochemical, water splitting, producing those devices that will produce hydrogen by just using water as an input and water as an output. So SANEDI is funding us because we have shown that we can use solar energy with nanoparticles and produce a pot that can be used by people who are cooking, people who are drying gari, some product of cassava, in a clean way without the actual effects on the environment by using wood for rural women in Togo, in Nigeria, in Cameroon. So this is a very nice project that is funded by SANEDI and Department of Science and Innovation. So we always acknowledge the Department of Science and Innovation on the work that we are doing. And also our perovskite work has reached a great maximum. And we just started with this kind of work maybe in 2017, but right now we can show you a very good number of publications. And then on the work that we are doing with polymer solar cells is that we have this collaboration with the University of Zambia. And we are at that stage of the second level of tier funding, because we have shown them that we can produce this polymer solar cells, and we want to be funded so that we commercialize that. Thank you very much, colleagues.
Thank you very much, Mansai, for that very interesting presentation. The floor is open for questions. You can either raise your hand or post a question in the Q&A or the chat. I'm not sure which is available, but either of those would work.
I can see a question on the chat there by Mornay van Rooyen.
I saw, I think that's maybe a rhetorical question.
Okay, but let me just talk to him. Mornay, this is the responsibility of all of us, that when government is calling us to some meetings, let's all go there and make a proper noise. If you can get platform on the radio station, TV, go in there. It's very difficult. Government is not really listening to us, but as we push in, they are listening. It's gradual, but they will come to that.
Good. Thank you. That is that's encouraging to know, and I think we must keep that in mind. Right. Any questions? There are no open questions. There is a raised hand from So Lila, let's see if we can, right. Okay.
Hi, sir. Can you hear me?
Yes, you can. We can hear you now. Please proceed with your question, Zulile.
Okay. Okay. Thank you very much, Prof, for such a great presentation. I am not in the solar technology research. I'm in other emerging devices research, but I just want to ask, generally, how has the research of developing solar cell has successful in or has succeeded in coming up with a balance between device performance and addressing issues of environmental impact of these devices in terms of reduction of electronic waste, which is another burning issue. I know that this kind of research are supported by the UN, but the same UN is having laws that are addressing or working towards reduction of environmental pollution. And specifically in this case, I'm referring to electronic waste. I think silicon-based devices actually the reason why we have so much of electronic waste in the world. Now, how has the entire industry succeeded in trying to create a balance between the performance and reduction of the waste? Thank you.
Okay, thank you so much, Zolile. That's a very interesting question that whilst I'm doing the solar energy research to clean the environment, I'm also involved in a UNESCO chair in Canada and South Africa and Nigeria and Rwanda and Italy on the reduction of the electronic waste. And we're not going to speak like politicians here. We're going to speak like ordinary people. The politicians will be saying, oh no, South Korea is producing a lot of this waste and they're throwing it somewhere in Africa. Japan also, US, there is a dumping place somewhere in Africa for all their wastes, like the old computers or whatever, they just bring them here. So, but the way we have to address it is that all of us have to be responsible in reducing the electronic waste. Sometimes I freak when I look at people throwing batteries into the dustbin, it's like we need to educate the community at large. Not only when you say community, we think about just people who didn't go to school. No, every person in South Africa and in the world should be taught about the electronic waste, that things like batteries, we don't throw them anywhere because they are electronic waste. And actually they're carrying a lot of beautiful, expensive stuff, which we could be recycling. I think if you look at the solar, the cell phones, the electronic, the metals that are there in solar cells, especially the latest models of solar cells, it's very important, tantalum, cobalt, that can only be found somewhere here in Africa. So I think we need to be working together as a community to address the issues of electronic waste. Thank you very much, Zolile.
Thank you for that. I see there's a follow-up question from Monet asking, is nuclear the first choice and then renewable energy?
My view would be that the first choice should be renewable energy. Nuclear will always have that fear of what happened to Chernobyl or what happened to Japan recently. Is it Hiroshima? Not Fukushima. we'll be worried about that. But I think as the technology is evolving, is becoming better, we can still consider nuclear. But what is there that we have as a hazard with our own nuclear power station, the Quebec power station? So for me, as a person, I would advocate that let's work on clean energy investments than on nuclear. Thank you.
Thank you, Matsai. Any other questions?
Oh, that's another question.
I think
Still Monet's question.
still the open question that's been,
Okay.
there we go. Okay, that's been done. I was just curious about the work on the perovskite cells that you are doing. I mean, one of the issues with those, and I think you alluded to that in the talk, is the long-term stability compared to panels like silicon. Do you foresee that problem being solved to the same degree? In other words, that the panels will be as long-standing as working as silicon does?
It's a big problem for now. Stability is the issue because of the lead that is in perovskites. Some people are saying that lead, from the chemistry point of view, the basic sciences come in there, that lead is very little, but as Zolile was asking that question, it's still a threat to the environment. So what we have done thus far is that the stability is being addressed by replacing lead in the perovskites so that we have got lead-free perovskites, and the devices are coming out, but sometimes people are rushing to doing business than to produce the quality results that will be long-lasting and stable. So thus far, Rudolph, we are working, even in my lab, on replacing lead from general perovskites for stability. Okay, thank you. Zolile is there again.
Okay, I think if we ask Zolile, have you got a follow-up question?
Yes, this one I'm asking as a consumer, ma'am, please, Prof, please bear with me. The solar technology is still very expensive in South Africa for us as ordinary people to afford. Is it because like when you search just as a customer, like the panels are fairly affordable, but the whole package that will output that kilowatt hour that maybe you need at home, the package is still very expensive. Is it because of the cost of the storage devices that maybe is maybe the technology there is still very expensive? For we can afford the solar panels maybe, but the whole package, which I don't know if I can isolate the storage devices there as the one that constitute this high cost, or maybe the inverter technology. In your maybe view, what components here, like I think the main components are about 3 or 4, if I'm not mistaken, and the solar panel, I think they are fairly affordable, but like as I said, the entire thing is still not affordable to us. And if maybe we can isolate the contributors to this high cost of the package, like what can be done by these industries to actually get all of them to transform? Because if the solar panel technology industry is transforming or getting better and getting maybe renewable and sustainable, but the other industries, maybe the power storage industry, which is used in copper, solar cell technology, is not transforming, maybe they are not working hard enough. Have we maybe tried as maybe your community, ma'am, to actually get these other guys to actually work towards the same goal as you, and maybe one of which would be maybe the reduction of the cost. Thank you.
You're welcome. Mornay, I can see that I'm going to address your question also with this one, where Mornay is asking, why are solar batteries still so expensive in South Africa? Our biggest problem is policies. We have allowed China to go deep into our space. And you know, anything that comes from China will kill every business, will kill every form of idea of making things from scratch. What I think should be done in South Africa is to have our own manufacturing industries of the silicon panels. You are right, Zolile, the technology is still very expensive. And the batteries, remember, I want you to be aware that no matter how cheap these batteries can be, they don't last more than 2 years, whilst the solar panels can last to over 25 years. So I don't think batteries are a solution towards storage. According to me, the solution towards storage will be hydrogen and also wind power. And all of this, we still have issues in South Africa. We are importing most of these technologies. The companies that are supposed to be manufacturing small components like the connectors, you know, simple small components, they still find them cheaper to get from China. So as long as you have China in your equation, it becomes very difficult to deal with the high rise. So, but be aware that from $76 to less than 15 cents, US cent, is cheaper. And I went to a place where they sell the solar panels the other day, and I found that for you to cover your whole house with solar panels, you will need like maybe 50,000 rands. You know, not very big one, but you'll need like 50,000 rands, and which is very expensive for other people. That's why the banks are coming in to say you can take a short loan, a soft loan, and if it is towards solar panels, they will structure the interest in such a way that you are covered. Mornay, I hope you understand. You are happy with the answer. Thank you.
Thank you very much for covering that. There's a question from Luyanda in the question and answer box, asking, in terms of training physics graduates towards understanding solar energy, is there a program already ongoing, or is it still going to be initiated?
The programs are already ongoing. Understanding solar energy, like if you come to my group before, whilst you are doing the experiments and all of those, we teach you the basics of solar energy, how we do get the solar energy from the sun, where there's the inclination, the angle at which this solar energy had to hit your solar panel. So we're already doing that. NMNU, Ernst van Dijk, they are doing something there. University of Stellenbosch, they're already doing something. University of Fort Professor Meyer there, he's doing some things. It's already there, Luyanda.
Yes, indeed. I can just confirm that. I think there's quite a bit of research going on renewables, and sometimes at universities, not only in the departments of physics, but also in departments of chemistry. And I think that's a good motivation to have physicists and chemists talking to each other on the same campus, because there's often a lot one can learn from one another.
Yes. Okay, one other thing is that, Luyanda, in other universities like University of Pretoria, in the engineering, I know at UCT they have that, they do calculations about energies. They do different types of calculations about energies. so that if you are buying a solar panel, someone can tell you how much are you going to get from that solar panel for your house. Thank you.
Yes, so I think it's a very good development that you mentioned about the fact that people who've got solar panels on their homes can now actually start selling energy back to the grid if they don't use all of the energy generated. And that would definitely help.
Yeah, one other thing is that the government must work around those policies, because these days, for those who have got the whole solar panels on your roof, you are not being paid anything. I think people should be paid for helping with the generation of power.
Okay, thank you very much. Are there any other questions? We've almost come to the end of the hour allocated to the webinar, but there are there's an easy opportunity for a few more questions.
Brian, go to the last slide.
Yes, you're welcome to.
Last slide, please. Okay. Okay, there's no more questions.
Yes, I think you're welcome if you want to say a few words about the last slide.
Yeah, I would encourage all male physicists to systematically and consciously support women in physics in South Africa. We really need your support in training these women, in giving them confidence and assertiveness so that we can increase the number of women in physics. You know, in South Africa, they say Malibongwe in August, Womandla is another term that they have come up with, and especially the young people. Let's get our young people involved in what we're doing. Thank you very much.
Thank you for those encouraging words. I think that's a very important consideration to keep in mind. And certainly from the side of the SA Institute of Physics, we support the activities of WPISA very strongly. And during the August, during Women's Month, they have multiple activities ongoing. So I think we've come to the end of our time together. Thank you very much again to Prof. Diale for this presentation and for starting the conversation or keeping the conversation going in some respects. We much appreciate your time and your input in this regard. Thank you very much to all the attendees who've made the time to attend this webinar. You know, if you don't attend, then the speaker's message doesn't get conveyed properly. So thank you again, and I wish you all a very good afternoon and enjoy the weekend. Goodbye.
Bye.